inequality of each type. So first I'll start with number 4. So this is my disjunction. The two inequalities are connected by the word or. So I'm going to solve each inequality separately. So I'll solve the first. I would subtract 2 from both sides. So 5x is greater than or equal to positive 5. Then I would multiply both sides by 1 over 5. X is greater than or equal to 7. So I'll set that aside for a minute, and I'm going to box the other inequality in red. And my first step would be to add 7 to both sides. So I have negative x is greater than or equal to positive 5. X must be positive, so in order to make that happen, I need to divide both sides by negative 1. That forces x to become positive. 5 is now negative, but since I had to multiply by a negative over the inequality symbol will flip. So now let's go back and graph. I'll graph. X is greater than or equal to positive 7. So I put the solid circle. X is greater than or equal to means I want all of the numbers that are greater than 7, including 7. And then to graph this piece, x is less than negative 5. So negative 5 gets the open circle. And I would graph in the direction of negative infinity because I'm looking for all of the numbers that are less than negative 5, but not including negative 5. Now to do the interval notation, I start with the left-hand side of the number line. I start with negative infinity, moving up to negative 5, and the soft bracket, and I union the set together with the set that starts at positive 7, going in the direction of positive infinity. This gets a hard bracket because of the solid circle. So this is my typical OR disjunction example. The graph is broken. You have the two boundary points, and then the shading is traveling in the direction of negative infinity or positive infinity. The graph is broken in between. So there's no single number that makes both inequalities true at the same time. That's a typical disjunction. Now let's do the other scenario. Let's look at problem number 6. So this is my conjunction. It's written as a string. My job is to isolate the x in the middle. So what I do in one spot, I have to do in 3 places. So I now have negative 14 is less than or equal to 2x, which is less than positive 4. The next thing I need to do is multiply by 1/2 or divide by 2 across the board. And when I do that, I end up with negative 7 is less than or equal to x, which is less than 2. Always compare the two tails. Make sure that the left-hand tail and the right-hand tail, the relationship is true when you look at the inequality in between. The inequality symbols must be facing in the same direction for a compound inequality. Negative 7 is less than negative 2, so you proceed on with your solution set. So I'm first going to plot negative 7, and I'm going to give it a closed solid circle because it's a less than or equal to. And I'm going to put an open circle at positive 2 because it's the strict inequality. What this arrangement is telling me is I'm looking for all of the numbers between the two boundary points, so I shade in between. This is my typical conjunction and scenario. It means that the range of numbers that are highlighted in red, if I choose any number from this highlighted red region and slip it in for x, I'm going to get a true statement. I'm looking for numbers that are both greater than negative 7 but less than 2. And note that negative 7 would be included in the solution set, positive 2 is not. And I would like to set up number 8 on the screen just because of the negative in the middle. And then that will be it for the video. So let's look at number 8. So I'm going to isolate the x in the middle. So my first job is to subtract 1. And I have negative 48 is greater than negative 8x, which is greater than or equal to negative 64. Being careful with your signs. And now, to isolate the x, I need to divide by -8, multiply by -1/8 in all three spots. So -48 divided by -8 gives me +6. X is now isolated in the middle, and -64 divided by -8 gives me +8. But since I had to divide by negative numbers, that means that both inequality symbols have to flip. And then always check the relationship on the end. Is 6 less than 8? Yes, it is. That's a true statement. That's a true relationship. So then you carry on with the graphing. And here, let's see, I would have an open circle at 6, a solid circle at 8, and I'm shading in between. It's actually a small solution region, but that would be my typical and conjunction outcome for this problem. But the reason I'm doing this on the video is to make sure that you know the -8 right here, when I take care of that, isolating the x in the middle, I have to reverse both inequality symbols.